In this video, I'll show you how to write a Taylor series for a function. This is question number 2. The question reads, calculate the sine of the angles in 10-degree intervals from 0 to 90 degrees using 2, 3, and 4 terms of a Taylor series expanded about 45 degrees. According to this formula here, this is how you write a Taylor series, and they're asking us to expand about 45 degrees. So, our a value in this example is equal to 45 degrees. They're asking for a lot of information in this question. So what I'll do is show you how to write the Taylor series to 4 intervals, and then I'll have a table that's already filled out just to see how your calculator compares to what your Taylor series provides when you evaluate the function at those intervals. Let's go ahead and do this. Starting with this term, we want to evaluate sine when it's 45 degrees. Using our calculator, we'll write down sine of 45 degrees, make sure that your calculator is in degrees, minus sine 45 gives me the square root of 2 over 2. Also, according to the Taylor series, we need to find the first, second, and third derivative to write down 4 terms of this series. The first derivative of sine is equal to cosine x, and I will evaluate this when x is equal to 45 degrees. I'll do that next. F double prime is equal to negative sine x. Same thing. At 45 degrees will be evaluated. At f triple prime, we have negative cosine x. And just for good measure, let's find the fourth derivative. F fourth prime, we have positive sine x. Now, let's find out what cosine at 45 is. Cosine at 45 is equal to the same thing, square root of 2 over 2. How about negative sine? Well, remember, sine 45 is this, so this will be negative the square root of 2 over 2. This one will also be negative square root 2 over 2, and this will be, once again, positive square root 2 over 2. I'm going to start to write my Taylor series. I have f at x is equal to f at a, which was the square root of 2 over 2, plus, and this evaluated at 45 gave us this, times x minus a, x minus 45 degrees, plus, or instead of 45, if you choose to use radians, you can replace this with pi over 4. It's up to you. Moving on, now we take this number, the square root of 2 over 2, and it's negative, and we divide it by 2 factorial. This ends up becoming negative square root of 2 over 4 bracket x minus 45 degrees raised to the power of 2. For our fourth term, we take this as our first factor, negative square root of 2 over 2, and this time it's 3 factorial. 3 factorial is equal to 6, so I'll multiply this 2 with this 6. 2 times 6 is 12. So the square root of 2 over 12, multiply 2, x minus 45 degrees raised to the power of 3, and this is ongoing. Now that we've written down our Taylor series, let's go back to the question. They want us to calculate the sines of an angle between 0 and 90 in intervals of 10 degrees for 2 terms, 3 terms, and 4 terms. Now this is going to take a long time, like I mentioned. I do have a table of everything filled out, and let's analyze this for a moment. Had I evaluated it at angle 0 for the 4 terms, I would have ended up with this outcome. Whereas a computer such as your calculator would take it to many more terms. The more terms you add, the more accurate it is. Let's take a look at 50 degrees. At 50 degrees, our series would have given us this outcome, whereas our calculator would have given us this outcome. It's not a big difference. The only difference here, if you take 6 decimal places, is the last two numbers. Also, what's interesting to note is how the Maclaurin series compares to the Taylor series of the same function, sine x. These graphs show the percentage error of the two series when compared to computer outputs. Notice that the Taylor series gives less accurate results than the Maclaurin series with the same number of terms. This table represents the completed answer to the question, and that is how to write a Taylor series for a function.